Hey, good afternoon and welcome to our first session of the Hamilton Science Faith Forum, which is a chapter of the Canadian Scientific Christian Affiliation. For those who don't know me, my name's Janet Warren. I'm the coordinator of the chapter. If anybody has any ideas or wants to help out, let me know. If you're not on the mailing list already, you can go to the website and sign up. Our next event is going to be November 17th, and that's going to be a watch party, which Alan and Margaret have kindly offered to host. So the CSCA 50 committee is having a special lecture. So it'll be on Zoom, but we're going to gather and watch together and perhaps meet early for share a meal or something. So there will be more information coming up on that. So once again, thanks to McMaster Divinity for allowing us to use this space. And also, I need to recognize and acknowledge that McMaster is located on the traditional territories of the Mississauga and Haudenosaunee nations within lands protected by Dish with One Spoon, One Pie agreement. So without further ado, I'd like to introduce Alan Dicker, our speaker for today. Alan is a longtime member of the Hamilton Science Faith Forum. He's a retired geology professor here. And I think even before his retirement, has a keen interest in researching biblical history, archaeology, etc., and has done a lot of research and has written quite a few books. Here are a couple on scientific commentary on Genesis 1, to be specific, and from the Stone Age to Abraham. And then he's also written a boring book on radiogenic isotope geology. So you're not interested in that one. Anyway, today he's talking about a provocative question about whether Joshua did really fight the Battle of Jericho. Welcome, Alan.
Okay, thanks a lot, Janet. Well, it's not so much whether it's boring, it's the fact is you can't afford it because the textbook's $250.
Wow.
The others are a lot cheaper than that. Thank you all for coming. And let's say that this is going to be a quiet revolution since there's only a few of us here, but I'm going to suggest it's going to be a significant revolution, but we'll see, right? We'll see as to whether it's revolutionary or not. Okay, so as it says here, I'm going to largely follow what I've got on the screen. This is for the benefit of those watching it online as well, when it will be recorded on YouTube. So there are two widely favored dates for the biblical Exodus, which are around 1450 and 1250 BC. And about 40 years after the Exodus, the first event of the Israelite conquest of Canaan was the Battle of Jericho. Radiocarbon dating of the destruction of Jericho gives an age around 1550 BC, which is therefore incompatible with both of the proposed dates for the Exodus. If you can't reconcile the date of the Exodus with the fall of Jericho, biblical archaeology is dead. In fact, many people have said that biblical archaeology is dead. So this is hardly a revelation. William Dever, prominent archaeologist of ancient Israel, presents himself as occupying the middle ground between what we could call biblical maximalists and minimalists, which is to say, maximalists are those who accept the Bible as a record of historical events, whereas biblical minimalists essentially reject the Bible as a record of historical events. So Dever presents himself as the middle ground. So this is what he said. Not only is there no archaeological evidence for an Exodus, there is no need to posit such an event. We can account for Israelite origins historically and archaeologically without presuming any Egyptian background. As a Syro-Palestinian archaeologist, I regard the historicity of the Exodus as a dead issue. despite this symposium's raising it again. He was referring in 1997 to a symposium he was participating in. But this view that the Exodus is a dead issue, yeah, is pretty much the standard thinking, I would say. So why should we re-examine this topic? I would say for Christian believers, this is actually a deplorable state of affairs. If there's no Exodus, the Passover is meaningless, so is the sacrifice of the lamb, which is a problem, I would say. The key to the problem is accurate radiocarbon dating of some of these events. Over the past 20 years, there have been significant advances in radiocarbon dating, which offers the prospect of new constraints on the Exodus and the Conquest. Okay, so the principles of radiocarbon dating. Take a deep breath. Now, the radiocarbon method was invented by Willard Libby in 1949, for which, of course, he won the Nobel Prize. It's based on measuring the decay of carbon-14 activity, it's radioactive, of course, from a known starting point, which is defined as modern radiocarbon activity. So we have the equation here, A, which is the measured activity, which is measured, used to be measured by radioactive counting, but is now measured by mass spectrometry. The measured activity is equal to the initial activity, which is defined as modern radiocarbon, times e to the minus lambda t, where lambda is the decay constant. That's inversely proportional to the half-life, which is a more familiar term for most people. Calculated ages, little t, using this equation, are called conventional ages. And as measured initially, this is the initial research of Libby, as measured, we're in good agreement with known historical ages as seen in the diagram. So I need to just explain the diagram then in relation to what I've just said. So on the left-hand side, percent of modern radioactive activity, radiocarbon activity. So that's starting from 100%, obviously. That would be something that's just died. I should perhaps just digress to say plants and animals absorb radiocarbon from the atmosphere. So then once a plant or an animal is dead, then the radiocarbon decays away, and the curved line there defines the trajectory of radiocarbon decay. And on the right-hand side, that is calibrated using the decay constant as the conventional radiocarbon age. And the bottom axis is the known calendar age. So these samples here are a series of samples of known age. Tree rings, a Bible, in other words, the paper that the Bible was made of, various Egyptian artifacts, which were all dated by radiocarbon. And as you can see, there was reasonable agreement between the known age and the measured age. So that's the basis of the method. Now, the problem is that atmospheric radiocarbon activity is not, in fact, exactly constant. Radiocarbon is produced in the atmosphere by galactic cosmic rays. So, in other words, coming from the rest of the galaxy, not from the sun. These cosmic rays generate neutrons when they collide with air molecules, and the neutrons in turn nitrogen-14 into carbon-14. So this is the origin of radiocarbon in the atmosphere. But galactic cosmic rays are deflected by the solar wind, which is kind of what's shown in this picture here. The solar wind's coming from the sun, and it's blowing past the Earth. That's that thing in the middle of the blue splodge is the Earth there, and the solar wind is affected both by solar intensity and also by the Earth's magnetic field, and therefore both of these factors influence the galactic cosmic ray flux. Okay, so this is what we measure. Now, on this plot here, we're plotting quote unquote delta carbon 14 per mil. Per mil means per thousand, and therefore, on a scale, this plot shows that variations from 1 to 100, so that will be 10% of the total variation of radiocarbon, the total amount of radiocarbon. Okay, so that's quite a significant variation. Now, if you recall the diagram I showed you of the the dating experiment by Libby, you would have noticed there was some. Actually, I'm going to go back. You would have noticed there was some scatter on the diagram. The points actually don't all fall on the line. So these variations in atmospheric radiocarbon were only, borderline issues when the method was invented, or they might be just significant. But in order to obtain accurate ages, calibrated ages, we have to take into account these atmospheric variations. And just for the record, the large changes, which meaning over thousands of years, are mainly caused by the Earth's magnetic field, and the short-term variations are due to solar activity, which are on the same time scale as sunspots. All right, so on the next graph, we're going to transform this same plot into, instead of plotting radiocarbon in the form of variations per mil, I should just have said in this plot, these radiocarbon measurements are initial. In other words, they've been corrected for the age of the material to what their state was like when a tree first grew, when the ring of a tree first formed. But what we're going to plot now we're going to plot calendar age against the true age. And the variations we're going to zoom into a small part of this graph to see the variations. Okay, so what I'm trying to say is this wiggly line here, which goes across the screen, this wiggly line here is the same wiggly line that I just showed in the previous diagram, but magnified and on a slightly different scale, right? So now we're plotting conventional radiocarbon age in years BP, that means before present. We're plotting it against calibrated radiocarbon age, which is usually stated as years BC, before Christ, obviously. Okay, so conventional C14 ages before present are turned into calibrated ages using the calibration curve. Now, as you can see, the curve has wiggles. So steep sections of the curve yield the best calibrated ages. For example, if we take, if we start at a measured radiocarbon age of 3250 before present, and the arrow keeps wanting to disappear as soon as I stop, and trace it across here, it hits a steep section of the curve and therefore should give quite a precise calibrated age would result. But 3350 years before present, which is this pale blue represents the analytical uncertainty of an actual measurement. In other words, the age is most likely to be 3350 years, but it could be anything from 3320 to 3380. Okay, so that's like a statistical uncertainty. When you take this statistical uncertainty and you take it across the calibration curve at this point here, with all these wiggles in a subhorizontal section, the result is what you might call disastrous. Okay, this dark blue plot shows the probability of the different ages, the solution. And so what you can see is, well, the age is probably between 1600 and 1700, but in fact, it could even be outside that range. You know, basically almost an uncertainty of almost 200 years, which is frankly no good to anybody. All right, so these are the complexities of using radiocarbon dating. All right, so given that background, which hopefully gave you some feelings to how it works, let's talk about a specific dating problem. And the problem here is the eruption of Thera Santorini volcano, which was a major Bronze Age event. Now, you might say, what's that going to do with the Battle of Jericho? Well, obviously, we'll get to that. So this is basically a test case. The Thera volcano erupted about 10 times as much material as Vesuvius. It completely destroyed the island of Santorini in the photo. It's 15 kilometers across. So all that stuff that's now sea, that was the volcano, right? That's how big it was when it blew up. This major event could define the transition between the Middle to the Late Bronze Age, which is defined as roughly around 1600 BC. Now, part of the problem is nobody quite knows what the Middle to the Late Bronze Age is. You know, it's a change, but like a change in what? Caused by what? It's a sort of, it's a convention whose basis is not perfectly defined. But perhaps perhaps what caused it was the eruption of this giant volcano. Or perhaps what caused it was the Exodus, or perhaps they were the same thing. Okay, so dating the Thera eruption is a test case for Bronze Age chronology. In other words, if we can't date something as big as this, the eruption of this giant volcano, what hope do we have of dating the Exodus, which is semi-invisible historically? Okay, so this is the issues we're going to talk about for 5 minutes. So the ash cloud from the eruption buried the town of Akrotiri, which has been excavated. This is like a version of Pompeii, only it's even more complete. As you can see, houses there are preserved up to the second story. So Akrotiri is a time capsule containing pottery and wood materials from before the eruption. The problem is that radiocarbon dating has consistently given older ages, say more than 1600 BC for radiocarbon, compared with pottery, which is consistently given ages below 1550 BC. So we have a discrepancy of, well, a minimum of 50, maybe 100 years between radiocarbon dating and pottery dating. Sorry about all the vast number of scare quotes. Anyway, I think they're valid to some extent because it's fairly scary. All right, so pottery dating is subjective. Well, most people would agree with that to some extent, although pottery experts might be a bit cagey about whether it's subjective. They would probably say it's not subjective. Carbon-14 dating of old wood, such as house beams, is also problematical. It can seriously overestimate the age. So, for example, you have a house in Akrotiri that burnt down when it got hit by all that volcanic ash. So the roof beams were carbonized. The house was built 50 years before the eruptions, say, and the wood was 50 years old, or maybe more, when it was turned into a wood beam. So the radiocarbon age for the wood beam could be 100 years older than the eruption. So it's not a very good constraint. On the other hand, short-lived samples also have problems. Short-lived samples such as seeds avoid the old wood problem of the beams of the house, but they make radiocarbon dating subject to wiggles in the calibration curve, as we demonstrated in the previous plot. Now, if you look at this particular plot, what we have here is the white curve is the old calibration curve called IntCal 1998, and the gray curve is IntCal 2020, which is the new calibration curve. And you can see that in some places, it's almost exactly the same, and in some places, it's substantially different. If we use the new calibration curve and the same 3350 date, then the pink graph is the resulting probability of age distribution. You can see that now there's a bigger peak in the middle, which is good, but there's also a whole bunch of other peaks, you know. So in other words, even with the new curve, it's still a problem because we've still got all that, the uncertainty across here, 200 years of uncertainty. So what can we do about that? Well, what we need is a better sample. So this is the ideal sample. Trees alive before the eruption would combine the advantages of both wood and seeds for dating. So this picture on the right is an olive branch that was recovered from the middle of the ash layer, which is on the left. As a matter of fact, the ash layer you can see is in 2 layers, but I mean, that doesn't really matter. The volcano had more than one sort of eruptive stage. That's a detail we don't need to worry about because that was only months apart, you know. Okay, so the olive tree was growing at the time of the eruption. It still had bark attached. And furthermore, under the tree, buried under the ash, were a bunch of dead leaves, carbonized leaves. And the argument is, well, that shows the tree really was growing when the ash killed it. Okay, so this really is an ideal sample. This is the result. Okay, so what we have here in the middle of the picture, this represents 4 wooden blocks that were sampled from the branch. Because they're blocks of wood, they're quite big samples, and so they're able to get very precise ages, relatively very precise, and those are shown by the spots with the error bars here, these 4 here. So, dating these 4 blocks of wood in a series, as you can see, they are contiguous. They're like in a row. My arrow keeps disappearing. 4 blocks joined in a row allows, it creates a little sequence of ages, which can then be, sorry, another scare quote, wiggle matched with the calibration curve. So in other words, it's a unique solution. The four radiocarbon ages, which will be measured on the y-axis, have a unique fit to the calibration curve, which therefore locates the bottom one to come to solve for the age. Okay, so the age of the eruption is the date of the bark, which is on the outside, which is here. But the important thing here is that the older blocks of wood anchor the bark to that steep section of the curve. Without this anchor, the bark could be anywhere from here right across to here. So it could be up to 70 years younger if we just had the bark only without it being attached to the 4 blocks of wood. Okay? So this is what we might call a cast iron date. We've got such great control from all the factors of the experiment, if you like, that it's this is as good as it gets, pretty much. But in actual fact, there's even more, because we can compare this age. Well, I don't know if I actually said 1608, actually, or around 1610 BC. This radiocarbon age of 1610 BC can be compared with the aerosol record in ice layers from Greenland and Antarctica. Okay, so in Greenland and Antarctica, it snows in the winter, you get a layer of ice, and then it stops over the summer, and then you can basically see yearly bands, and they can be counted to individual years. And these bands get contaminated by volcanic eruptions. And typically it's a signal of sulfate, although large eruptions can create dust layers as well. All right, so, oh yes, and another thing is that we have ice core from Greenland and Antarctica. So Greenland obviously in the Arctic, Antarctica obviously in the Antarctic. So we can, based on how big the signal is in the Arctic and the Antarctic, we can make at least a crude statement about where the volcano was. Okay, so if the Arctic signal is big and there's no Antarctic signal, then the volcano must have been in the Arctic. If the Antarctic signal is big and there's no Arctic signal at the same time, then the volcano was in the Antarctic. And if 50-50, it's somewhere in the tropics. It's not, you can't say the exact latitude. But so here's Theras, in the tropics, somewhere in the tropics, subtropical. There is no volcano in the subtropics any time after Thera for 100 years, okay? And there is one 50 years earlier, right? So what you can see is there is no other candidate except this one here for the Thera eruption, and this is dated at 1611 BC. So pretty impressive agreement. 1608 for radiocarbon, 1611 for the ice core dating. All right, so now switch gears to Jericho. And we come back to the dating in a moment. All right, so this is a cross section through the destruction layer at Jericho. It's very well established. Digging by several different groups of archaeologists have established that a mud brick wall was built on top of a stone-faced rampart. So this this is the stone facing of the rampart of the city. And the mud brick wall was built up here above the stone rampart, and basically all fell down and ended there where the red color is. We presume it was caused by an earthquake. It obviously wasn't caused by human activity, because if it was pushed down by a battering ram, it would have fallen the other way. It has all the marks of earthquake collapse. And as you can see, because the mud brick wall fell outside, it basically made a ramp that all the invaders, the anonymous invaders, had to do was walk up it to get into the city. The excavators, for example, John Garstang and Kathleen Kenyon, well-known excavators in the 20th century, they found many storage jars full of grain that had burned during the conflagration. It shows that the attack must have occurred just after the spring harvest. Of course, in Israel, there's more than one harvest a year. This is the barley harvest that occurs in the spring. All right, so what about the radiocarbon dating of Jericho, which is kind of the where it's, you know, what we're coming to? Well, this is a paper by Bruins and Van der Vliet, 1996. So it's 20 years old, but it was very carefully performed. So they dated 2 sets of material, carbonized grains of barley, maybe, and burnt wooden roof beams. And I plotted them as a histogram there. And you can see, as you'd expect, these are the conventional ages. So we have, as I say, 6 grains of cereal grains, give an age of, they calculated a weighted mean of 3306 before present. And the roof beams give an age that's like 50 years older, something like 70 years older, which is what you'd expect, that a roof beam would be, 70 years older than the grains. That's very normal. All right, so now we have to take this. So we're going to, in order to get the exact age, we're going to focus on the grains. So we're going to take the age of 3306 and its error bars here, which were quite small because it was 6 samples. So there's an average and then a mean of the average. And then we're going to project it across to the calibration curve. And what you can see is it's going in just below several of the wiggles. So there are actually 3 intersections. It's slightly strange the way it intersects, but there's one here, and one here. I've colored the one, what we would call the most important intersection, in darker blue. So this is the most likely age of the grains of the destruction, 1535 BC. But it is possible that it could have been in 1520 BC or 1600 BC. So we can't rule these out yet. All right, so how does that compare with the eruption of Thera volcano? So if the Thera eruption coincided with the Exodus, then the sack of Jericho would be 40 years younger. Okay, that's assuming we believe, you know, the account in Exodus where it says the Israelites were wandering in the desert for 40 years. Well, the 40 years is a little bit suspicious because it's a magic number. On the other hand, it's justified in the account by saying, well, it had to be long enough for all the disobedient Israelites to have died. So if you accept the generalities of the story, then they're consistent with the period of 40 years. Okay, so it's not just a 40 years alone. There is the circumstantial evidence to support it. All right, so 40 years from 1611 would be 1571, which is the vertical dotted dashed line here. But you can see, interestingly, that this intersects with a bump in the calibration curve, such that the intersection is well outside of the error envelope. The inference then is it's not likely that the Exodus coincided with Thera because it doesn't fit. This is a very improbable intersection. It's much more likely that the Exodus was 40 years before the Jericho date. So that's what I'm saying here. The best date for the Exodus is 1535 plus 40, which is 1575 BC. The 1535 BC Jericho destruction was followed by approximately 500 years of almost complete abandonment. What I actually mean is there was an attempt to build something 200 years after, but it was fairly minor. The city wasn't inhabited again until the Iron Age. So a date for the Exodus during the Middle Kingdom, which is to say 1250, 1450, any of those dates, is extremely unlikely. That's the conclusion. All right, so now let's talk about the Egyptian context here. In 1575 BC, Egypt was ruled by the Hyksos kings. Their capital city was in the Delta. This city was it was called Avaris. It was later renamed Ramesses. It's over here. Now, the mention of the building of the city of Ramesses in Exodus 1:11 is often used to argue for an exodus during the reign of Ramesses. You know, the argument is, well, if they were building a city called Ramesses, obviously it was during the reign of Ramesses. But if we look back at Genesis 47, we find another mention of Ramesses. Genesis 47 is in the time of Joseph, you know, when the Israelites first got down to Egypt. So that couldn't possibly be during the reign of Ramesses. So therefore, it tells you that biblical authors are using the name Ramesses as a gloss. In other words, someone updated the biblical text because they knew that nobody knew what Avaris was anymore. So they're going to call it Ramesses just to make it clear where it is. And this is basically an anachronism. Okay, so it means that the name Ramesses of the city is not evidence for the time of the Exodus. Okay, so this is roughly what Avaris looked like. It's basically on the Nile. You can see there's a bunch of islands, and there are different neighborhoods there which have been excavated. It's quite a big excavation. It's been going on like 50 years. And this summarizes the history of the settlement of the city. Now, I know it's a wee bit complicated, so let me take a couple of minutes. So across here, you've got these different neighborhoods, 6 neighborhoods. And this is the time scale in blue. And, and this in pink shows the occupation history of the different neighborhoods. So what you can see is occupation began in the 12th dynasty here. That's the end of the Middle Kingdom. But it was most developed, which is to say all of this stuff, in the 13th to the 15th dynasties, which is called the Second Intermediate Period, SIP here, including the Hyksos dynasty. And then after that, we have a major abandonment horizon, which is here. But the date of this abandonment is disputed. All right, so we're now going to compare the age information. So, yeah. On the left here, we have pottery dating. And on the right here, it's just got hidden partly, but anyway. On the right here is the radiocarbon dating. And unfortunately, the radiocarbon dating gives ages which are essentially 100 years older than the pottery dating. Sound familiar? Similar? We've heard this one before. Now, it's agreed by Egyptian chronology that the beginning of the Middle Kingdom, that's the 18th dynasty here, is pretty well established at 1530 to 1540 BC. But what happened before that is pretty unconstrained. In other words, I'm saying, yeah, this box D2, Bitak, the excavator, he assumed that every section lasted the same duration. Well, I mean, that doesn't follow at all. I mean, there's no law that says rate of sedimentation has to be constant. Seems clear there's an extra 100 years that's gotten lost in there, in that D2 layer. The simplest explanation is that the abandonment actually occurred over a period of time, maybe 2 phases. The first phase was the Exodus. The second phase was the defeat of the Hyksos kings by Pharaoh Ahmose, which is the beginning of the 18th dynasty. All right, so this would mean that the Pharaoh of the Exodus will be a Hyksos. Okay, so Exodus 1:8 says, quote, "Now there arose a new king over Egypt who didn't know Joseph." And John Ray, 1960, argued that the Hebrew word translated arose implies rose against, suggesting a new dynasty, a change of dynasty, in other words. So this could have been the rise of the Hyksos dynasty. An Egyptian historian called Manetho, who is quoted by Josephus, says that the Hyksos were cruel. They enslaved women and children. This judgment is often dismissed, but I mean, it does actually agree with the biblical accounts, you know, that the Hyksos were not as nice as everyone says they were. Okay, so that we now need to go back to Canaan to have a look at the consequences here. What happened in Canaan? Well, we're quoting here from Diva again. Every single Middle Bronze III site excavated thus far in Palestine shows one or more destructions precisely between about 1550 and 1480 BCE, so devastating that most sites were abandoned for a generation or more thereafter. And he also says, about Shechem, phase 1 wall E was destroyed probably in the final Middle Bronze 2C destruction of Shechem around 1540 BC, leaving 75 centimeters of tumbled and burned mud brick up to the present surface of the mound. Okay, so the point of this argument is to say, yeah, the transition from Middle to Late Bronze in Canaan is a major destruction layer. And it occurred in the early 16th century, 1530. Now, Diva goes on to say, the victory account of Thutmose III, found inscribed on the walls of the great temple of Amun at Karnak near Luxor, lists dozens of identifiable sites in Palestine and Syria, which the pharaoh claims to have taken on his famous first Asiatic campaign around 1482 BCE. Well, the thing is, he's actually nudged the date upwards to try and make it work. Actually, this campaign was almost certainly around 1460 BC, because it was in the 23rd year of Thutmose's reign. So, in fact, it's well after these destructions. And we see the same thing at Megiddo. Megiddo is very important because its conquest is recorded in the Karnak relief, as I said, 1460, but it also has a lot of radiocarbon dates, and these dates place the transition at 1530. So that's 70 years earlier than 1460. So in other words, Diva's model doesn't actually work. He's sort of nudged the dates to try and make it fit. Most of the collapse occurred before the campaign of Thutmose III. So the evidence that these destructions were caused by the Egyptians is very weak. The best explanation is, hey, they were caused by the Israelites. So I'm nearly done now. Let's compare the Israelite and the Egyptian conquests. The Israelite conquest was around 1530 BC, and after the conquest of Joshua, they withdrew to the hill country, which of course is the brown stuff here, which is now called the West Bank. the land of milk and honey, which was what the Holy Land was described as, is not some kind of description of a Garden of Eden. It's actually a description of the upland steppe, because milk means herds and honey means wild scrub. So land of milk and honey actually means the upland steppe, which the Egyptians were not interested in. The Egyptian conquest focused entirely on the coastal plain, which is, of course, is green, because that was where the money was. Okay, so just to finish then, how does this compare with the biblical chronology? Well, to make things complicated, we actually have two alternative chronologies in the Bible. 1 Kings chapter 6, verse 1 says that 480 years elapsed between the Exodus and the building of Solomon's temple. But the durations of the judgeships, Book of Judges, if you add them all up, you get 633 years between the Exodus and the building of the temple. So 633 years, that's a pretty good agreement with 610 years, which is what you get from the radiocarbon evidence. So which of these two dates is historical? Well, the 480 years in 1 Kings is firstly a round number, and secondly, it's the multiple of two perfect biblical numbers, 12 and 40. We should expect that this number is symbolic because it separates two priestly institutions, the tabernacle and the temple, a very symbolic transition. Another example of the use of biblical perfect numbers is in Matthew's Gospel, chapter 1. It says there were 14 generations between David and the exile, even though Chronicles lists 18 generations. So what does this tell us? It tells us that biblical perfect numbers are meant to be symbolic, not historical. So, conclusions. The dating of the Theia eruption demonstrates the accuracy of reliability of radiocarbon dating. Only in Exodus in 1575 BC is consistent with archaeological evidence for the sacking of Jericho and the conquest of Canaan. The account in the Judges is based on historical sources. It's not just made up history. Joshua really did fight the Battle of Jericho. What you learned in Sunday school was correct, and it's the scholarly accounts of history that have to be rewritten. Thank you.
Thanks very much, Alan, for that fascinating presentation.
Any questions?
What are the chances of a scholarly account being rewritten? And it's an ongoing work, and people take it serious enough to try and line up in Sunday school?
Well, we can say for certainty that the history books will be rewritten because they're in a constant state of being rewritten. But we couldn't say how they'll be rewritten. That's for history to see.
You don't think anybody happy?
Okay, so let me just paraphrase what John is saying. So I didn't spell it out exactly, but yes, what did you call them? The evangelical view is a date of 1450, and the traditional conservative view is 1250. And in actual fact, although I didn't just say it here, there was a book published, I don't know, was it last year, or a discussion book where the different dates were presented in a discussion, and actually 5 different points of view, one for a 1450, 2 for a 1250, 1 for an 1150, and 1 for no Exodus at all. So yes, as you say, well, that was reading that book that made me think, actually, you guys have all got it wrong.
Just to clarify, evangelicals are split. and you probably know that, split on dating, early date and late date. And mainstream scholarship may not be happy with changing the calibration, or not the calibration, changing the pottery dating by 100 years. I'm not an archaeologist, let alone a ceramicist, but they're pretty persnickety about their, as you mentioned, their precision. I'm not saying this is a problem for you. I'm not saying it makes you wrong. So
one way of looking at it is that both of the camps, if we can call it that, of 1450 and 1250, have produced cogent arguments to why the other guys have got it wrong. And therefore, it is a relatively logical response to say, well, maybe they both got it wrong. Of course, as I briefly mentioned, there is actually a third date of 1150, which arguably is very weird because it postdates a famous Egyptian stela of Merneptah, which mentions the Israelites at a time which is before, mentions the Israelites supposedly in Israel at a time before 1150. So most people would rule that one out of contention. Yes, well, it's going to be contentious.
Maybe you said this already, but can you clarify the margin of error? So the 1575 plus or minus.
So, of course, the interesting thing is that we can make an argument that the dating of Thera may be possible to date it to the exact year. I should say this is also debated and argued. In fact, the paper was published this year, which said it wasn't that old. So using the same evidence, obviously they misinterpreted the data. This is the data of Bruins and Van der Plicht, 1996. It's 25 years old. It should be redone, but it was done really to the best possible standards that were available, and therefore there's nothing intrinsic to the data which says that, things should always be tested, but the data are as sound as you could be. In other words, we've got a good distribution of the grains there. We've got two outliers, the dark blue. We've got two outliers there in the histogram, but they're, on equal side of the mean. As a matter of fact, I did do a quick sort of statistical test, which is to say, what happens if you delete either of the outliers? I mean, that's a normal test. I forget what it's called, like a reliability test. And the result is you get a new mean, which is basically on the edges of the envelope here. So at the top and the bottom edge of this error envelope. So the error envelope perhaps is slightly understated. It's maybe an optimistic error envelope. But the important thing is that the general result is very sound. So to answer the question precisely, statistics can be very misleading. People can juggle statistics, especially a technique that's called Bayesian dating, which involves, which is a very powerful technique, but it basically involves feeding the data into a black box for most people, and then out pops an age, and you say, well, this date is based on Bayesian modeling, so it must be true. What I'm trying to argue is that the most reliable dating method is what you can actually see. So the principle for arguing the reliability of this age is that the dark blue intersection here, if the age is actually younger you can see that it's on a relatively steep part of the curve, so it goes all the way down here. So in other words, even an error of 20 years is not going to allow the calibrated age to be significantly young. It's still going to be over 1500 BC. Okay, that's the point I'm trying to make. So in other words, it's a very stable result. On the other hand, the wood gives a conventional age of 3370, which is up here in this part of the curve, which is also a very stable section. So combining them both together, it means that the maximum age can't rise more than 20 years and the minimum age can't fall more than 20 years. So even though the argument is quite complex, I would say it's a very stable age, and it's unlikely it actually is wrong. Although other people have gotten random errors, random dates, but this date is more well constrained than any of the other stuff that's been done.
Okay, let's thank Alan again.
Thanks very much.